All right, there will be some slides that I recommend to take a picture of because it's a summary of some points. You will see those slides because it has this camera symbol there. And if there's anything you learned, please share this on social media. Security is a great focus to share and to learn about. So nice to meet you. My name is Natalie. I was born in Belarus. My Russian is really not good enough. I apologize for this. I studied computer and software engineering. I really loved university classes about parallel programming. And when I was in university, what I was hoping to do when I grew up is do parallel programming, something like NVIDIA. So I learned languages like CUDA. But then I moved to Berlin. And Berlin is a city of hard software. It's completely not a city of hardware. That's how I found myself using Go. And that was 2014. And since then, I'm pretty much using only Go. I got to work in several companies. If you want to ask about Berlin startups, please feel free to do this as part of the questions. And in 2017, I attended DEF CON. DEF CON is the world's biggest security event in Las Vegas. And the way that it works is that you just show up and you get a ticket. So it's not like you can buy a ticket in advance, and it's not like it can sell out. So that's how it ends up being something like 25,000 people that meet together. And the conference is a few days non-stop. So it's 4 or 5 days, 24/7. In the sense of, if you come in the morning, you can go to talks, you can go to participate in CTF competitions, so capture the flag, like hacking competitions, or you can participate in some social activities. But if you come at 4 a.m., minus the talks, this is pretty much the same. So it's a really non-stop, really long event, and it's all about security and it's all about hacking. And my mind was blown. I didn't change careers into security, but I remained really curious. Once a year, I participate in a CTF in the Chaos Communication Congress in Germany, and I try to bring awareness to security since then. My recent job was as engineering manager in Frogster. That's a Berlin-based startup that is fighting fraud in online payments. Basically, what the company does is when somebody is buying something online, they're sending the transaction data to this company, and the company has up to 250 milliseconds to look at the transaction details, decide whether this is fraud or not fraud, and send back the response with the explanation why do we think this is a yes or not fraud. As you can imagine, you need to be really quick because nobody likes to wait more than a few seconds when you buy something online, and it has to be really robust because we have really serious SLAs. SLA is a service level agreement, which basically means between us and our clients, what % of the time do we guarantee we will have uptime. So the way to measure SLAs is with nines. If you say our SLA is 4 nines, that means that 99.99% of the time you have uptime. The SLAs that we had mostly in place was 5 nines, which means 99.999% of the time our website has to be up. That is something like 40 minutes of downtime per quarter. Downtime is for things like when somebody made a mistake, when you have a rolling upgrade, or when you want to test something. So you have very little time to make mistakes. Those were basically the reasons why the company used Go for the backend from the very first day. In addition to all those requirements, we have to be PCI compliant, which means you have to go through a specific certification because you're saving credit card data. So there's a person who comes once a year, looks at all the code, asks questions, and then decides whether we're doing the best effort to be secure or if there's anything we need to change. One of the requirements for that is to have all the developers go through security training into how to write code in a secure way. Based on this training, I created this talk. It's exactly all the practices we have in place. And I want to say a very special thank you to Elena Grachovich, who's based in Berlin, and to Baruch Sadugorski, who is based in California, who inspired to give this talk. I want to also say thank you to everybody who reviewed and contributed with corrections and tips. Security is a great topic. It changes fast. Anything you see here today is relevant for now. It might not be relevant for 6 months in the future. Please always stay up to date. So we begin. When we talk about security, you see the traditional 7-layer model. And in this talk, we will focus only on part of them, starting with data. So when we talk about data, what comes to mind? Passwords, right? You want to keep your passwords safe. And a very easy way to do this is that if your user is providing them, you let the database encrypt. What happens if you need to generate your own passwords? So before we dive into this Go code, quick question: how many Go developers or people who are familiar with Go code are in the crowd? 0. All right, cool. No, then I don't see well. 2. All right. Then we have this piece of code. What it does is it imports the formatting library, and it imports math/rand, so that's the default random library. And what it does, it basically says generate a random number. And my question to the 2 people in the crowd, is this a good code? Meaning, will it create a random number every time I use this software? If you think that yes, raise your hand. I see no hands. I think you have the right thing. This is actually going to generate the exact same thing every time, for the reason that our seed of the random is a constant number. And if your seed is constant, then the numbers that it will be generating are the same. So next attempt, let's try time.now. This is not random, this is constant. This is not constant, this is actually a value that changes every time. So question to everybody, not just the Go developers. Do you think this will make a random code? If yes, raise your hand. I think I see no hands. All right, you got it. This was somewhat random, but you can see in the middle, I hit enter fast enough to generate the same value twice. And if I'm generating the same value twice just by hitting enter fast enough, the computer will definitely generate many times the same number. So that's also a bad idea. What is a good idea? How about crypto/rand? So now we're importing the crypto library that generates, based on crypto, random numbers. Who thinks this is a good idea? Raise your hand. I see one hand. All right. You are right. That's indeed a good choice. And then let me ask you a question. What does the crypto/rand library do?
It reads dev random. It's like random number generator built into system. It's really of good quality.
Oh my god, this is the first time somebody ever answered this. Bravo to you. Usually at this point people are like, wait, that's a good question. So thank you for knowing this. That's really nice that you know what you're doing. And kudos to you. So please use random numbers. Please know what you're doing with them, or how are they generated in the first place. Right, so we have our passwords in place. Next, we're going to use user personal data, things like email or address. Let me tell you that in Europe, this information is very much of a big deal. GDPR and so on, you know, Europeans' privacy. So logs is an easy way to get the data leaking, because any developer who has access to logs can pull lots of data from there. So the recommendation here is to mask the logs, meaning that you don't necessarily have to see the content, like address of a user, to know that the logs are showing that correctly the functionality of the system. And tools that do this is, for example, Sumo Logic, it's, for example, Splunk, it's, for example, FluentD, and even Elastic can have a feature. The enterprise version has this feature that, based on the user permissions, it will show you the logs or mask the logs. Cool. So we talked about data. we talked about passwords. Now it's about secrets. Secret management is not always easy, right? So what would be the very first tip you give to somebody who is managing secrets? Don't store this in your code. What you see here is just the result of searching on Google, the very much default way to find a password, and you have many, many results, which means many people are storing their secrets. So their passwords to specific applications or like usernames and so on, openly on GitHub, which is sad. And if you want to fix that, the way to do this is not just to make a git commit where you remove the password, because revision history works in the way that you have information online, and even steps that try to cover for other steps, they're also documented. A good way to do this is Kubernetes. Anybody in the crowd using Kubernetes to manage your secrets? All right. Super. Hi there. I see you. Questions for you. If you want to say yes, please wave. Do you know how secrets are stored? Do you know who can access the secrets and modify them? Do you know how can you check who accessed the secrets? Do you know how they're transferred to the application? So this is a zoom into part of the documentation where it says the recommendation is to store secrets as environment variables, which is a pretty common practice. And I want to ask you to take a picture of this. If you're using Kubernetes for secrets management, run this on a laptop of one random developer in the team and see what values you're getting. Spoiler alert, what you get, if you don't have user management or profiles set in place, what you get is the password of everybody who's using it. A good solution not to end up in such a situation is to use a dedicated secret management tool, for example, HashiCorp, which is open source and even written in Go, and it helps you transfer the values from the app, not from environment variables, and it has a great SDK which makes using it pretty simple. Okay, switching to code. How to keep it secure from being exposed to all kinds of threats. So input validation, it's a pretty common practice. If somebody is writing a microservice that you know it's going to be exposed, you know you're going to do things like check buffer overflow, you're going to check if the ranges are valid and so on. But do you check the same type of validation when you're just using it internally, so for the front end to consume? If you're getting something from the internet, for example, a third-party app that some person that you don't necessarily know has used it, are you checking inputs and doing all kinds of other validations before you're using it? My tip is that if you're consuming somebody else's code, don't assume that people are taking the extra mile to be safe, and do the test on your own. And if this code that you're writing, don't assume that microservices will remain internal. And even if you have really good documentation in place, don't expect people to read it before they use it. So what I'm saying is that make sure that you do all the testing inside and basically block the potential troublemaker user from utilizing in a bad way your library. SQL injection. So when you go to DEF CON, you can try to do newbie training. So basically recommendations on how are very, very basic hacking methods, let's say. And one of the first ones that you're being taught is SQL injection. And you think that because this has been taught everywhere and discussed everywhere so many times, this will be safe. It's not. A bunch of websites are still open to this vulnerability. And let's look at a code example. We're going to jump straight to the spoiler. What you see here is that there is an SQL injection in the very first function. And what you can do to be safe is to escape the variables, put only sanitized values in the database, use name parts, say how much parameters you're expecting, and generally use the driver to make sure that this is done right. There are several tools that can check for you for injections, weak random generators, and so on. And in Go, one of the popular ones is called GoSec. Running this example for the GoSec, we get this report. So it points out two problems. The first one, in green, is the weak random generator. The severity of the problem is really high. The second problem that it recognizes is the SQL injection, and the reason that the severity of the problem is only medium is that there is a chance that this piece of code will not be read. If you want to block people, so for example, you're a team lead and you want to make sure your colleagues are not using libraries that they should not be using, like math/rand, you can use tools, for example, depguard, which is an open source linter written in Go that checks if there's a blacklist of packages if anything is not located there. It is built with Golang CI lint in mind, compatible, great documentation, really good tool. Because it is part of the, because this is part of the build, this is basically making sure that whatever linters you have in place, all will be executed, not just the one that checks the libraries. Scope of debug handlers. Everybody in the crowd of the Gophers is using pprof for profiling. Pprof is a great tool for the purpose of profiling your application, and recommended to do so you'll get to know the guts of it, and they're recommended to use in a smart way. This example is not a smart way because anybody who will go to the website will immediately have access also not just to the business logic but actually to the profiling of the app. The reason you don't want to expose the profile of the app to people from the internet is that by knowing how things behave and how things are expected to behave, you can hack the app. In CTFs, that's what you do. You try weird things until you find an edge case that shows you a specific error, and then basically you start your way in. A good way to go about this is to have dedicated handlers for different purposes. So for example, the first few are the internal ones, so pprof, for example, and then you have several that are open, that are external, and you can also have ones for health and so on. Basically, it means that a different endpoint, one endpoint serves one cause. People who read in the documentation that you have some endpoints can use them, but they don't know that you have endpoints that you use internally, and that's how you stay safe. Another thing that you can do is define with something like Nginx that only internal traffic is able to access something like the profiling. And do fuzzy testing. Best joke, in addition to being hilarious, this is also a great way to go about CTF. Always try to break things. Dependencies. Dependency is practically somebody else's code. When you're using the standard library, that's fine, but how about third-party library? Most of us in this room are using external libraries, and we're trusting people, strangers on the internet, who wrote random pieces of code into our code base. Now, my question to people in the crowd is, what do you know about your transitive dependencies? So the dependencies of your dependencies. Basically, how familiar are you with the imported libraries that your imported libraries are importing? This is a picture I took earlier this year at .go conference. This is Dave Cheney. He's a very famous Go speaker, and he presented this piece of code that basically asking people, if you have a random library from the internet, are you sure that you don't have such a piece of code there? And what this piece of code does is it is nullifying any error check. This question made many people feel pretty sad because everybody imports lots of libraries, and even if you're checking at the library that you're importing, practically no one is checking the libraries that those libraries are importing, even though it would be a good practice to do. So let's talk about what is the checklist that you need to have for libraries that you're importing. What is the code quality? When you're looking at a new library, look at the code, think of it, is it good, is it secure, do they check for SQL injections? What is the test coverage? If it's very partial, don't use it in production. How active is it? If the last time somebody touched this piece of code was 3 years ago, probably security patches were not made. Who are the maintainers? Can you trust them? Are there enough of them out there? Is the code written in a secure manner? Or can it be something like profiling is exposed to everyone? What are the licenses? If you want to take a picture now, this is a great link that I can recommend everybody to read on how to suspect your dependencies and what to look for when you're considering to import a library. Now let's look at some examples of cases that happened in the past where people did not look at those checklists and what happened after that. The first and the most famous one probably is the Equifax breach. So Equifax is an organization in the US that has a credit score. It has all your personal information like social security number, birth date, and whatnot. Equifax is a huge organization, and someplace in the code they use Apache. And generally this is a very great set of libraries to have, but occasionally it can happen that a security breach was found and the right thing that you have to do in this situation is to update. But they missed the announcement that a vulnerability was found, update needs to be made, and from the moment that the breach was found until they placed the update took 4 months. During those 4 months, 148 million records of American citizens were stolen. Basically, entities of 148 million Americans is now available on the internet because of this breach. The reason that this happened is that it's a huge organization, and once they realized that they need to do this, they still didn't realize who is the person or who's the team that has to do this. And so what we can learn from this is picking safe dependencies is not enough. If it's Apache, it's safe, but only if you keep it up to date. If you do it once and if you import this once and forget to keep this up to date, at some point it will no longer be up to date. And that's not just Apache, that's anything on the internet. Know the transitive dependencies that you have. In small systems, it can very well happen that you use libraries, but you're not sure what your transitive dependency is. In huge systems, it can very well happen that you just don't know all the imports that you're using. Continuously monitor new discoveries, because you need to stay up to date, and there's tools for this. Dependabot is a great tool for this. It creates a pull request to dependencies to make you stay up to date. It supports Go, and it's actually part of GitHub. GitLab has a similar tool that is built in, not yet supporting Go. But basically what this tool does is whenever you have a library imported and there is an update for it somewhere, it opens a pull request and it shows you the difference. So you can look at it and decide whether you want to update or keep it as it is. Continuing with the tips, upgrade swiftly. If you know you need to update, do it fast. This means that you need to have the infrastructure for this, in the sense that if you, for example, release code only every 2 weeks or something like this, you need to have emergency rollouts, and you need to know who is responsible to do this. And this opens interesting questions. For example, if you have several teams that are using a specific library, and one team is pushing to update this, will all teams have to update, or will you start using different versions? So these are decisions that you need to make in advance before you have an emergency. Next example. Last year, a JavaScript library maintainer handed over to another person because he was done with it. The new owner embedded code that was trying to take your Bitcoin. Anybody remembers this?
Yes.
Maybe. Yes, okay. I hope not because you were part of this. Takeaways. Multiple maintainers is better than having a single maintainer, because being an open source contributor or even maintainer of a library is a really bad job. You work for free and people just complain about things that they're missing. If you burn out, you get yourself in a situation where you just want to get rid of this instead of finding somebody safe to give it to. Another takeaway is that automatic upgrades can have risks. Think about all those people who just said, oh, a new update to the version, yeah, okay, bring it in. And then immediately your website started stealing, or was the means to start stealing Bitcoin and other cryptocurrencies from your users because you didn't read what was there. Lock your dependency versions. Don't update before you know what's inside. Next example is from 3 years ago. Sure, good amount of people remember this. So it's a library that was made of 11 JavaScript lines of code. Basically what it was doing, it was padding with spaces from the left because many frameworks in JavaScript depend on this. This person decided at some point that he's not happy with the situation and removed this library from the central repo. The way that it works, the NPM, the build tool, is that whenever you pull for updates, if there's updates in the remote repo, it pulls to your local computer. If a specific library was removed from the remote repo, it will remove it from your local cache. And so you wake up in the morning, go to work, do an update of the versions, bam, the website crashes. You start investigating why, how did that even happen? Our takeaway from this situation is that immutable dependencies are a must. Whatever steps you need to do for this, make sure that you have this. Vendoring is a reliable option. Go modules is a great option. Central repositories can be risky. If you're using any software that has something like this, just be aware that this situation can happen. Last example, the funniest and scariest of them all, is about a popular JavaScript library where one of the maintainers does not like the US Immigration and Customs Enforcement, the ICE, and he decided to fight them by prohibiting companies who collaborate with them to use the package. So you see examples right here in the code, for example, Microsoft, for example, Palantir, for example, Amazon. In the new license, he clearly states that those companies are not allowed to use this, and you know that using a product against the license would expose you to lawsuits. This change was accepted and it was merged. That's not all. The person behind this wanted to make this change without changing the license name and the major, which is how you usually do this in open source. So imagine you're the person who shows up to work, pulls the updates, just regular version update, minor, nothing big deal, no name of the license didn't change, there's no major change. Suddenly, your company is exposed to huge lawsuits, and as a huge company that's being exposed to huge lawsuits, just because you did the small change that now changes the license in your software. Luckily, this was, yes, it was merged, but it was quickly reverted. So, takeaways, licenses can be very complex and they can be considered on security issues on their own. Even minor upgrades need attention, because it's true that the open source agreement is when big changes happen, you would bump the major, but it's just an agreement. Nobody checks this and things like this can sneak into code. So to summarize, we saw 4 examples. We saw the Equifax breach happened because it took long to patch. We saw how a JavaScript library that changed owners was stealing CryptoCoin. We saw how a JavaScript library that was padding zeros broke websites because it was removed from the central repo. And we saw how a small version update almost exposed huge companies to huge lawsuits. And to summarize general tips on dependencies, I'll start with controlling your dependency tree of your dependencies, but also of your transitive dependencies. Be careful when you add new dependencies. Continuously verify them. Look for security patches. Read carefully before upgrading versions. Always have a reproducible build, so you can rely on your existing dependencies and upgrade dependencies swiftly. Bug fixes, security patches, everything needs to happen fast, but also make sure you don't do this automatically so you can actually look at each and everything. This is another recommendation where I can suggest to you to take a picture. Right, thank you very much. Exactly 30 minutes. Thank you for your time, and please ask questions.